Okay guys, I just want to send you a couple of work-through examples from your homework just to make sure that you're doing them right here, but I'm primarily concerned with quadratic functions, specifically in standard form, that is our y equals ax squared plus bx plus c form, and how we could easily determine their graphs, that is to say where their vertex lies, what the axis of symmetry's equation is, and then assess the situation with respect to domain and range. So let's just recall that when we talk about something in standard form, the vertex is always at negative b over 2a, and then the y value that we would get if we were to go plug that x value into our function. And our axis of symmetry with respect to it, remember that our axis of symmetry is a vertical line, and so is given by x equals a number, but that number would have to be the same x value as the x value on our vertex here, because recall that a parabola, at least any parabola that I've ever seen here, is symmetrical about this vertical line that runs through it. And so whatever your x value of your vertex is, it's going to be the same as that x value on the equation of this line. So in order to find the vertex here, what we're going to want to do is assess the situation with respect to a, b, and c. We have a as 2, b is negative 8, and c is 3. So our vertex is going to lie at, let's start with our axis of symmetry here. We get negative b over 2 times a. And so we would get negative 8 really over 2 times 2 here, which really gives me a positive 8 over a positive 4, which comes out to be 2. So really quickly here, let's go ahead and put x equals 2 as this vertical line, this imaginary vertical line that's on our graph. We know that our vertex has to lie on this. Furthermore, we want to know what the y value at our vertex would be. And so because the point would be 2 comma f of 2, our job then is just to go find f of 2. And so luckily I brought a calculator with me here. We could go easily find f of 2 by plugging it into our function. So we would get 2 times 2 squared minus 8 times, in parentheses, 2 plus 3. And so we end up with a y value of negative 5. So we get 2, negative 5. So that would just mean that we go right 2 and down 5, and that would be our vertex value here. And so would this open up or down? Now, it's kind of an important question. When we talked about transformations of functions or graphing them previously, we always looked at this a value as our vertical stretch or shrink of our graph. And so we're going to do the same thing here. This would just mean that our graph opens upward. Having a positive a value means our parabola opens upward, and it would be vertically stretched by a factor of 2. So instead of like our parent function where we go right 1 and up 1, we're going to go right 1 and actually up twice as far. We're going to go right 1 up as far as a tells us to, which in this case is 2. So this would be our graph right here. So with respect to domain, every quadratic is always going to have a domain of negative infinity to infinity. But with respect to our range here, we can clearly see that our range values will only be from this y value down here at our vertex, and I've actually gone down too far, this y value down here at our vertex on up to positive infinity. So we're going to say starting at and including, and in this case I'm going to say because this is the point 2, negative 5, at this minimum value here, negative 5, and then going up forever and ever, but not including infinity. So this is pretty important to me that we recognize, first of all, that this parabola had a minimum value. And if we said, well, what is the minimum value? Just to be clear on this, we have a min of negative 5. Now, if I said, where does that minimum occur? We would say that the min occurs at x equals 2. So we would say that when we talk about minima and maxima, of course we're talking about y values, and when we talk about where they occur, we're talking about the x value at which that occur. So how could I, in this next problem here, tell you what the min or max value of this parabola would be and where it occurs, and then also the domain or range, if I don't even graph it? And so I suppose just using the fact that a would tell us whether it opens up or down, we could clearly assess whether or not if it opens up it has a minimum, or if it opens down if it has a maximum. Furthermore, we could find that minimum or maximum just by finding our vertex without even graphing it here. And so what I want to do is look at this one here. We say, well, first of all, does it have a min or a max? Looking at the a value here, would this open up or down? And because our a value is positive, okay, a is positive, then we would say it opens up. And because it opens up, this must have a lowest point, or in other words, a min. Okay, so it has a min, it does not have a max. In terms of what is the minimum value then, well, we're trying to find the value of the minimum, which means we're actually looking for the y value at which our graph gets the lowest at, Okay, so what we're going to do is we're really finding the y value of the vertex. Well, that's easy enough to find. Let's start with this. Axis of symmetry, because this is in standard form, we get negative b over 2 times a. So our negative 12 over 2 times 3 would actually give us a 12 over 6, which comes out to be 2. So our vertex then would have to lie at 2f of 2. Our only job is to go find what f of 2 equals. So what is our function value when we plug 2 into it? Let's go ahead and do this here. We would get 3 times 2 squared minus 12 times 2 minus 1. And so I end up with negative 13 is my y value here. So interestingly, what I can tell you is that the minimum value of my function is negative 13, but the reason why is because we were really trying to figure out what's the lowest our graph went in this case, and it's just that y value right there. So in terms of domain, because it is a parabola, it's always going to have a domain of all real numbers, or negative infinity to infinity. But in terms of range, how can I tell you the range if I know what the minimum value of my graph is? And so what you're going to have to imagine is, well, if this graph, at the lowest it ever goes is negative 13 and opens upward, maybe something like this right here. Actually, it'd be 2 comma negative 13, which is where this is exactly. We found this. Basically, we could say that the range would have to be negative 13 and up. If we had something that had been opening downward, we could have easily said, well, then it would have been negative infinity up to negative 13 and stopping there. But in this case, we definitely didn't have that. We had the blue graph. So use your a value to tell you whether it opens up or down and has a min or max. And then just go find the vertex to tell you what that min or max value is and help you find the domain or range. Cheers.